everyone. My name is Yuexing, and as you see right now, I'm at Cornell University, Ithaca, New York. Hopefully everyone can share my screen right now. Perfect. So today I'm going to talk about patient-oriented frameworks for clinical decision selections employing machine learning techniques. Currently, I'm a PhD at Cornell University, so thank you, Mai, for introduction. And it's my honor to do a presentation at AI and Women at ICML 2022. So let me introduce a little bit about the frameworks. You may be a little bit confused about what is the patient-oriented framework and how do you develop it. So previously on, there's an overview-oriented framework, which we will abbreviate it as OOF. It is considered as the most commonly used framework in the digital health domain, since it's followed the mantra from Ben Snyder-Ben, which is overview first, zoom details on demand. It is used as a traditional framework for a long time. However, in the recent time, especially after the pandemic, during the pandemic, a lot of patients and physicians, also the care providers, they discovered that this OOF is not that good to use anymore. So based on different type of discussion focus groups, we're thinking about proposing a new innovative framework, which is called as a patient-oriented framework. So this POF will recommend treatment plans, treatment options, care management options for patients based on their own preferences and body conditions. So after building the POF, we're also thinking about, is there a better way to make this decision-making faster and more efficient? So we come up with another framework, which is called stage-oriented framework. This SOF enables the users to make informed decisions with the format of the POF while optimizing it by leveraging these group-wise comparisons. So let me compare the differences between OOF and POF first. So we can see that the overview-oriented framework, which starts from models to the final end users, which in our case, it's patients. So let's simplify this OOF as a decision tree, which every model's based criteria, it will divide it into new models, and in different criteria, it will pop up with different new models. So these models in our case are considered as care management options or treatment options. And in the end, there will be a list of the models, and that will be considered as an overview-oriented framework because it showed all the process. It gives an overview first, details on demand, and zoom and filter in between. So in our POF, we would like to reverse this traditional framework, which means based on the patients, their own preferences, their own health conditions, and different factors, they are going to find the optimized treatment options. So it's not like the original one, it will be a new one. So to make it much easier to understand, I made a prototype for the overview-oriented framework and a POF. So I'm going to show it here. For the instruction, we will see there's 10 machine learning models. You will see near neighbors, linear SVM, also like random forest, Gaussian process, neural nets. And we're using a data set, a public data set, to show the demo. So there will be a confusion matrix. And then after pressing on each of the confusion matrix, we can compare this specific model with the others. So you can see some parts of it. We can also use mouse over to see the exact data points and make comparisons. So this is the overview, which means that we will see all 10 models without any clear comparisons between them. For the patient-oriented, we will pick up one model based on the patient's preferences and their health conditions, and we will make the comparisons. For example, we already picked one called nearest neighbors. We're going to compare the specific data points with the other machine learning models until it's satisfied. So that will make the whole decision progress much faster and find the optimized model much easier. So for the stage-oriented framework, it will be called as SOF. The stage-oriented framework, well, based on the patient-oriented framework's outputs, based on all the outputs, we will divide it into different criteria. So here are the criteria set by the patients, and it will divide it into different stages. So we grouped this we grouped this treatment option plans together as a group, as a stage, and then we will find the priority between these groups. So they will find the best priority, second priority, and third priority. By doing this stage-oriented framework, we discovered that the whole comparison progress is much faster. So after we're proposing this frameworks, we're thinking about an exploratory study to better evaluate these frameworks. For our first evaluations, we're thinking about the time. How's the time complexity going on with this new frameworks? POF and SOF both significantly improve the efficiency from the OOF. So we can see this time complexity table. For the best conditions for overview oriented, it will be O of n squared, which means n is the number of the treatment options. So if there are more treatment options, there will be n squared numbers chances to review all these options. That will be a huge long time. Building on OOF, we have POF, and that shortened this decision time to O of k in the best conditions. Although in the worst conditions, they still do the comparisons, and the average will be O of n. So how many models there are, how many comparisons they will have. It will reduce the time complexity. For SOF, it will also increases from the POF. It goes to O of k, which means a constant number of time, and k is less than n. K is less than the number of models. So from this table, we can see how this time complexity decreases from our traditional frameworks. It will also help the patients to make their clinical decisions much faster, more efficient, and also help them to find the most optimized model. The second evaluations we're thinking about is called user evaluations. So this evaluations is still ongoing. We're still conducting several clinical interviews with clinicians, physicians, and we're also working with different focus groups to get the feedback from this staff, nurses, and also some administrative staff. For the future directions and projects, I would like to talk more about the health and the mental health. So these two projects are ongoing right now. The first one is called as the physician-centered, literature-based clinical decision support system. So this system, which is originated from our patient-oriented framework, discovered that physicians, when they're making clinical decisions, they also need some support to help making decisions. So we're thinking about a literature-based clinical decision system, which can help them to make the decisions much accurate and much faster based on the literature evidence. And the second project is for future clinics in Metaverse. So Metaverse right now is a virtual reality platform, and it can connect with several intelligent devices. And we're thinking about, is it possible to implement the clinics, especially for outpatients, to build their whole medical system in the Metaverse. And we will create solutions for the virtual healthcare architectures. So in this screenshot, you will see me using the VR Quest 2 headsets, Meta Quest 2, to interact with the whole Metaverse environment in the system. So we can easily have an avatar, which can help us to maintain our anonymous. And then we are also going to have a health chances in the waiting room and discuss with the physicians. And on the right picture, it also shows a old lady. She wants to use these metaverse platform to interact with the physicians and in a much efficient way. Here's a little demo video I would like to share for the patient-centered applications. Let me see whether I can share it. So this is how the virtual reality actually implemented in our phone, and how can we use these VR things to interact with our healthcare space and interact in the physical conditions. Let me see whether I can get the sound.
How's your right arm feeling today? And there's also a just wear a mask. It's really virtual reality, so you can see you're playing around with this icon. So you can select, for example, good. And it will list to you, great, you have an appointment with Dr. Daniel Lee today at 3 p.m. Eastern Time. Is this information correct? We have two. One is no, this info is false, or yes. So let's select yes. Then we will see insert your name below after you finish the waiver. Before we go into the future clinics, we also need to sign some waivers. So here we will read the waiver and type the response. For example, my name is John. Done. And it says, great, Dr. Daniel Lee is waiting for you on the 5th floor, 520. So we can check out whether it's 520. Okay.
So this is an example of how we use the VR applications for the patient center and how it helped to alleviate the short staff problem after the post-pandemic time, and how it will help the patients to have a better experience in clinics. For the last slide, I would like to show an example, a product from the healthcare decision making. Since I'm also the senior software research lead at Vita Innovations, I would like to talk about like the decision making in this industry. So this is actually a decision making platform interface for helping this emergency room staff to keep track of the patient's conditions when they're in this waiting room waiting for the emergency. So they can easily track the data, and they can also help to make decisions based on different scoring systems. Any questions, welcome to ask, and I'm also going to stay after it. Welcome to contact me through email or contact me through LinkedIn. And here is my references. Thank you.